Hello, everyone. I'm excited to share with you today how to generate IFC for your Lambda-based applications using appCD. For this demo, we'll be using an open source Lambda application that we created called Retroboard. This is a Python-based application that has 3 different Lambda functions, and the functionality within Retroboard is a simple application to create retrospectives. You can see a running version of the application here. Now let's go to appCD. I'm going to log in with GitHub. The first time you log into appCD, you'll go to a guided process to onboard your repositories. I'm going to select here, generate from appCD demo repositories. And these are a handful of repositories that we've created to play around with the tool. Let me select Retroboard. Now Retroboard has 3 different Lambda functions, and these will correspond to components within appCD. So here you can see the component for the API, which is located in function/API. Here's send email and send Slack alerts. Now let's proceed. Now I'm going to select AWS Lambda as my compute. And as you can see, we selected automatically 184 policies related to AWS Lambda applications. And these are security and operational policies that will be applied by default when we generate our infrastructure as code. Now let's proceed. I'm going to name my app stack Retroboard and click on the create button. Now the system is cloning that repository and performing static code analysis. This will be used to determine what are the infrastructure resources and other elements that the application relies on in the cloud environment. This information will then be used to generate a topology diagram that will let us look at the infrastructure architecture for Retroboard. Now let's give it a minute so I can complete the analysis. And this is what the topology looks like. Here you can observe the 3 Lambda functions and the infrastructure components that Retroboard relies on. Now, if we look at the bottom left, we'll see 3 different errors that we have to fix. These are validation errors for things that we cannot observe directly from the source code. So let's take a look. For the SQS, we need to give it the name for that SQS. So I want this to be a dynamic parameter. So I'll click on the top right to convert this into a variable that then will be generated into my Terraform. Let's do the same for SNS and for my other SNS topic. Now, one of the capabilities that you get from IFC is that we will generate the least privilege policies required for this Lambda function when accessing any infrastructure resources in AWS. For example, if we click on the lock icon, we can observe what is the policy that has been generated for the API function accessing SQS. So we're observing that for this action, we will need access to a KMS key, and the Lambda function will also need access for SQS send messages as it's sending messages to this queue. Similarly, if we look at this green icon, we can detect that the SNS topic for the send Slack alert function is being used as a trigger for that function. So this Lambda function is triggered by SNS. So now that we're ready, that we fixed all errors and that our policies have been selected, we can observe the infrastructure as code that appCD has generated for us by clicking on the IAC tab. This IAC can be exported by clicking on the top right and clicking Export IAC Files. This will download a zip file into your local environment. Similarly, if you click Push to Git, you will get instructions on how to use the appCD CLI to push this directly into GitHub. any other Git repository that you're using. Thanks again for watching.